Thank you. I'm looking for the folks from Intel Labs that are going to be talking about their experience with throughput on
Hi,
Ether.
Larry. Yeah. I'm Suresh Marikanoy. I joined.
Okay, great. So we'll get to that in a minute. Just a few bits of business before we get to that, and then we may have more time afterwards. But I think these items at the top we can knock off pretty quickly. So this is the first bullet is an on-ramp issue, which is Bala has multiple UPF configuration working with on-ramp. He basically Ansiblized Gabriel's work from before, and I just needed to connect Gabriel with him so that he can understand what kind of workload to put on it, just for verification that it's correct.
Okay, sure.
And I'll let you two exchange emails and take it from there. What I imagine is we'll point GNB Sim at it in one form or another. So it should be integrated once we can settle that question. We can integrate it into on-ramp.
Okay.
Second bullet is I just created an Aether Jenkins channel on Slack. What I intended that for, and we can purpose it however we want it to, but I thought it would be good to have a place that Jenkins posted results so that it's easy for whoever wants to follow along to say, oh, that job failed, I should do something about it. So I mean, we used to do this with Cord, right?
Yeah.
Yep.
And yeah, I think it would be interesting to at least see the results of the Aether on-ramp jobs. Yeah, maybe we don't need to look at all of the jobs that we've been weeding through in the spreadsheet, but at least the Aether on-ramp ones, I think that would be useful for everybody to see.
Good. So yeah, so I think we could. I agree. We don't want to pollute it with so much information that no one can make sense of it. But if we start with the on-ramp jobs, I'm interested in seeing those, and maybe a few other people are. And then if others want to add to that mix because they are paying attention, then that's great. But it's sort of like by request stuff gets posted there. We don't want to flood it with failures. That's depressing.
Yeah, we want to feel good about the stuff that's there.
So there are two addresses there. It's which jobs do we want to see, and do you want to see both success and failures or only failures?
What's the typical? I certainly want to see failures. I don't know that I need to see successes.
In the past, I've usually run two separate ones. One where you get everything, every single job, every single status, and the other one of new failures, i.e. something that failed while it was successful sometime in the last week, kind of thing. Simplest is just failures for now, and then we'll decide whether we want the others.
Yeah, I think that's good. So let's do failures for now. And I forget the exact number, but GS Labs has a nice set of on-ramp tests. We'll just post them. We'll post failures there. Every failure too, not just if it's failed.
Right.
The first failure.
Simplest is any failure. Just failures that were
I set it up
successful
private
last
because
time.
I didn't know how wildly popular this would be, but I can make that public if people want to keep tabs on. I guess I probably should do that. I'll make that change after the call.
Okay. All right, so
Okay,
I'll start.
Go ahead.
I'll start with pushing just the Aether QA on-ramp jobs. And if there are other jobs that people want, please file a ticket or, ideally file a JIRA ticket requesting them. Or DM me directly, one or the other, but I prefer the JIRA ticket if people know how to do that.
Okay, so let me quickly. I was just trying to quickly change it to public so that other people can get access to it. No, where is that? It's my created link channel. Settings?
Are you in Slack or in your Google?
I jumped over to Slack for a second just to try to Oh, here it is, changed to public channel.
Yeah.
Okay, it's now a public channel.
Okay.
Okay. Okay, so third bullet, David, I guess is you.
Yeah, just for those who are curious, we've been behind on Jenkins by about a year and a half. Finally got it upgraded to the latest LTS, as well as we're now running on a 2204 upgrade installation, as opposed to 18.04. So I'm able to use up-to-date plugins and packages and things. So far, have not observed any issues associated with the upgrade. Just kind of warning people, but at least
Yep,
now I
thank
can trust
Good.
issues.
Okay, fourth bullet, troubleshooting Gnode B. So we've got the starter kits in the hands of a couple of universities, and they are starting to work through the process of bringing them up, and it's been not completely smooth. It turns out that these are band 48 instead of 78, and I don't know what other differences there are, but they aren't exactly the same boxes that I had brought up and AJ before me. So fortunately, we're slogging through a lot of detail there, and progress is happening, and we're getting good response from Sericom and Moza Labs. So it's a slog, but we'll get there. And FYI, especially if you're one of the people that has one of these boxes and may want to bring it up, there's a Google Doc kind of collecting our experience. And at some point that'll get folded back into the overall Aether on-ramp guide, but for now we're just recording it there. So we have, I don't think we need to leave all the rest of the time for the throughput discussion. So I want to see if there's any other short topics that folks would like to address or bring to everyone's attention.
I have a quick question, Larry,
Yeah.
regarding the troubleshooting Gnode Bs. Are you fully concentrated only on the Sercom Gnode Bs, or are you planning to expand to other options?
Oh, certainly other options are always welcome, but at the moment, we are now troubleshooting. Yeah, thank you. It is literally the title, that is the Sericom. Yeah.
Okay.
That
Yeah, no,
does not by any stretch mean that that's the only thing we're interested in. It's just what we got our hands on right now.
Yeah, no, the thing is that for the project that we are currently working on, we kind of had to deliver some demo as part of the first task by the end of last December. And I kind of faced that kind of issues about basically, having a phone not connecting to the same infrastructure when using different bands. So that's what I was kind of more curious. But in our case, we are using OpenAir interface along with a USRP. And basically the limitation itself, at least on our experience, was that the driver for the phone itself, had those limitations. Because from the software perspective, or from the Gnode B side, let's say OpenAir interface combined with the USRP, there was not much different itself, but limitation itself was the phone. And depending on the phone that we had, we tried a few OnePlus phones, and also we tried a Huawei, I believe it was P40 or P30. So we see this difference. So typically with band 78, in general, at least there was some communication between the Gnode B and the phone, but band 41, for example, didn't really work. I wasn't able to do that much.
Yeah. So this is actually a spectrum of issues having to do with the UE, having to do with the PLMN that we choose, having to do with proper settings on the Sericom Gnode B. And of course, there's always the concern that we aren't connecting to the SD core correctly, but I think we've worked through most of those. So it really is specific settings on the Gnode B for this particular device. For example, if you aren't using SAS, and how to get the SIMs burned correctly. And some UEs not supporting all the bands. So it's a range.
Yeah. Okay.
So Yeah, I see Wuzhong on the call. Thank you for your help with the burner. I think that's actually the latest issue. We're not burning the sims right.
Mhm.
Anything else? Other issues?
So yeah, not issue. Well, just FYI. So I just started working on scaffolding the SDN for on-ramp. So my goal is to complete this by end of next week. So probably 2 weeks later, TST meeting, I think I can sort of show the code for that, and we can improve from there.
Great. That's fantastic. Well, I won't hold you to a couple, but in a few weeks.
Yeah.
Perfect. That's wonderful. Okay, so well, let me do one more call. If there's anything else. Okay, I will now stop sharing and let's hear from Intel Labs. Go ahead.
So
Yeah, thanks, Larry. Let me share my screen.
Yeah, please do.
Let me know when you can see my screen.
We see it.
Okay, thanks. So today we would like to present to the forum. So with respect to the performance test we carried on Aether environment. So the intention here is we have tried some experimentations with the different tools and in different modes, and we have observed issues and kind of optimizations we did, and how we able to get some good throughput in the Aether environment. This includes the kind of configuration and optimization we did in the configuration file and the system wise. So with respect to the performance, when we took the Aether initially, so our intention here is verifying against the 5G UPF. So initially we tried with the speed test. So that is the first tool we tried. So with that, we were able to establish the connections and we were trying. So the problem with the speed test tool we observe is it is not consistent because the speed test server it selects is not, we are not able to control. So every time in the environment when we try, we do see very inconsistent behavior, which creates very difficult for debugging the issues or do the optimizations effectively. So in order to make the control within ourselves, we tried the iPerf tool, so which helped us a lot in terms of achieving and debugging the issues. So that is the one so far we have used efficiently. Recently, we have added the T-Rex. So in our standalone deployments, we are using T-Rex. So we would like to emulate this environment in the Aether framework as well. So one problem with using T-Rex is, so in iPerf and speed test and all, we were using UE rancing. So the control plane and the registration, everything is taken care by those tools. But with the T-Rex, the one we used, we can't simulate that one. So we have made some kind of workaround in using the PFCP interface already the Aether environment deploying. So using the PFCP interface, we are simulating the control plane sessions. Then we were using the T-Rex just to pump the traffic uplink and downlink. So a couple of weeks back only, we were able to, functionality wise, we were able to test this against T-Rex, AAB against T-Rex. So we are in the process of scaling the flows and the throughput, packet size and other things. We are in the experimentation. Probably we will be in good position in a couple of weeks. Then we can plan for a demo on that one if really required. So in today's discussion, we are mostly concentrating on the iPerf. So and the IO modes, basically we have tested all three tools using DPDK as well as AF packet mode. So and we do see significant differences in these modes, of course, as it provides. So we would like to showcase today the iPerf in especially with the DPDK mode, where we can able to achieve good throughput. So before getting into the demo, I would like to showcase what kind of setup we are using for all three tests and how does it look like, so that you can get an overview on how does this environment is set up and how we establish the traffic. So for the speed test, as you know, our Aether AAB, we were deploying it in the one system, ICX5, and we were using the UERAN SIM to run on ICX3, and we will be using the speed test, which will eventually connect to the one of the speed test server on the internet. So, and this way we were, as I mentioned earlier, we don't have a control, and we do see inconsistent behaviors, which leads us to move with the hyper setup. So in hyper setup, so how does our environment looks like? It's almost like the same with the speed test. So we were running the UERAN SIM on ICX3 and AAB on ICX5. So for running the hyper server, we have added one more interface server. So ICX1. So all these connections are connected through the switch. So basically, we will be running our hyper server on one server. Then our UERAN SIM will run on the ICX3 where we were running the client. So basically, this will establish the connection with the UPF, and we will be starting the server and do the experimentations like running different kind of traffics, TCP, UDP with the different attributes and parameters. And the intention is to see what kind of traffic we were seeing, what kind of packet drops we were also seeing in the pipeline. So, and we will discuss in detail about that, what kind of issues we faced and how does we overcome that. And especially one thing to note with respect to the hyper here is, when we set up by default, when we are configuring the AAB, it was configured for it was not optimized for performance throughput. So basically my uplink QoS and the data rates are capped at the 10 Mbps, and similarly some kind of a slice. So what do we see is after we push to a certain limit, we do see the packet drops in the UPF pipeline, where the slice rate limit kicked in, and it is drops the packet certain after a certain threshold. So by default, these slices are not configured, the slice rate limiting things, or it is having a very not optimized value. So we have
a quick question. Sorry, could I also interpret that as saying that the rate limiting is working?
Yes.
Good, thank you.
Yeah. So we have optimized that values in order to get zero packet drops in the UPF pipeline. So that way we will make sure nothing impacts the UPF throughput, at least from the pipeline point of view. So, and I will very quickly just show the T-Rex and I will move on to the demo. So this is almost the similar to what we have with earlier, but in this case, as I mentioned earlier, the control plane sessions, everything we were simulating using the TFCP simulator. So we don't have anything externally. So we are, as of now, we configured around 10 flows just for the functionality testing purpose. And my T-Rex is running on another server, which is using the DPDK. Both ports were bind to the T-Rex, and it is using the DPDK mode, and similarly the UPF also configured in DPDK mode. So we were at least able to establish the traffic now in uplink and downlink. So as I mentioned, we are in the process of establishing the performance metrics and kind of what kind of range we were able to achieve and other things we were currently working on. So with that, let me move to the demo. I have captured the video for this purpose. I will explain. Okay. So before getting into running the test and see the throughput, I would like to showcase what kind of changes we did in the YAML file, the configuration file, for example, in order to improve the QoS, rate limiting, and other configuration stuff. So I just did a vimdiff comparison between the default one and the one what we changed. So if you can see here, basically we have by default the uplink. I think probably it is bit very tiny. and hopefully bear with me, and it is not much clear to so if you can see in the right side, it's a default one. On the left side, we have made the changes with respect to the configuration, and we just increase the bit rate and other stuffs in order to establish the throughput both in uplink and downlink. So, and we just configure for a trial purpose up to maximum 2 Gbps configuration. And similarly, and yeah, I changed this the color scheme. Hopefully, it should help us now a bit more. So by default, when we were running with the default configuration, as I mentioned, the uplink, we were not able to go beyond 10 Mbps mark because of these configuration restrictions. So we have changed this bitrate configuration for this particular UE group and other devices. And apart from that, we have added some kind of QoS traffic classes and other kind of parameters. And now whatever I'm showing, probably this is nothing to do with the performance point of view, but this is the difference how we were enabling the DPDK mode. So most of you might be already deployed this in DPDK mode. You might aware, in case if you haven't only used the AF packet mode. So these are all the kind of parameters we have to change in the configurations. So basically we might need to enable SRIOV, and you have to enable the huge pages and other kind of things, and your the resourcing obviously. So we have documented this procedure and we have raised another PR. So it will be the procedure should be available in the portal soon. So this specific whatever I highlighted, this is for the DPDK mode. Probably we can just skip through this and go to the performance aspects. So if you can see in that left side, so we have added the slice rate limit config. So in the down, because by default when we don't have that, the default configuration is very less, so which is having a significant impact on the throughput. So we have added this as part of the YAML file, 5G core YAML file, and we have increased the limits to the 2 Gbps for the N3 and N6 interfaces. So with that, so we in this case, just for your purpose, I'm just explaining what kind of windows, because I have made in the single window, I have prepared all the sessions. So I have already deployed okay, in the top left, I'm going to deploy the Aether UPF in DPDK mode. So I have already configured the prerequisite for the DPDK, which takes some considerable amount of time. So I do not want to capture everything here. Probably I can share the documentations later, and you can refer. So in the middle left, the UE RAN SIM. So I'm going to register my eNode B, and on the middle right, I will be registering my UE. The bottom right, I will be running my iPerf server. So you can see the ICX server 1. Then the bottom left, I'm going to run the iPerf client, and I will be running some sample throughput test, and we see how much we were able to get. So I'm going to just deploy this UPF, and since the other I have already just resetted the connection, the previous connections and all the parts, other things were cleaned up, and let's see whether it comes up and runs before we make any registrations. Probably let me just. Okay. Installation done. My parts and everything is up and running. So I'm going to just register my Gnode B now. You will see some kind of error. So this is because when the system comes up, it will take some time for the SIMAP and other configurations to be made. So before that configuration happen, if we register, then we are seeing that registration issues. That's why you see that earlier. I just re-registering now my Gnode B, and after giving some time in order for the configuration to propagate properly. And my Gnode B is registered. I'm going to register my UE now, and let me establish the tunnel. Okay, my UE registered and the interface came up successfully. what I'm going to do before running the test is I'm going to just ping my IPF server through the tunnel. So make sure the traffic is fine. So there is nothing needed. So on the top, the bottom right, now I'm going to run the IPF server. So and just one thing to note, even though I was referring to IPF, we were using specifically IPF 3. So when we are using IPF, we do see some kind of issues, and we haven't debugged it further. So we just used IPF 3. So that worked straight away without giving any headaches. So now I just started the IPF server on my ICX1 server, and I'm going to run my client now. So I just shown the command which we were using. So you might know the connection IPF, the client. I'm going to connect to the 172.31.29.3, and I will be binding my local I want this connection to be established through my UE tunnel, the one that we created, the UE SIM tunnel 0. So I'm just binding this to the UE IP. Then I will be testing here the UDP traffic, and I will be testing both bidirectional. And the bandwidth or the limit I have given is 1 Gbps, and the packet length or the the socket length I'll be given 1300. We did some kind of experimentations in changing these values differently with different rates, and we do see different when we are reducing the packet sizes and other things, we do see significant impact in the throughput. But the we were just showcasing the default one, what we achieve around almost close to 1 Gbps. So, and then I'm going to just start my client to establish the connection and pump the traffic. So, and you can see, and it is displaying on both server and client side. Almost I'm getting close to 1 Gbps. You can see a very small amount of packet drops around 0.5%, similarly, and around 1%. But if you increase or decrease the packet sizes and other things, this packet drop rate will increase significantly. Limit and other stuffs, we were seeing huge packet drops in the pipeline. So after configuring the optimizing the values only, we were able to achieve at least in this range. So, and I hope you know by default it will be we are using a single core. So as part of our experiment, what we did now, so we would like to do this kind of experimentation. We did this, okay, I am showing this in the DPDK mode. We did the same thing in A packet mode as well. There we were seeing kind of almost we were able to reach close to 700 to 800 Mbps. But in DPDK mode, we preferred because we were able, it was consistent, we can able to pump up the traffic. And we would like to do some kind of experimentations in scaling up the core and scaling up, because here we were using a single UE. So we were registered just a single UE and only one flow we were using. So we would like to scale the UEs more. That's why we were interested and moved to the T-Rex. So like configuring 5,000 flows and distribute the traffic and observe the behavior, how does it impact, especially with respect to the hashes and kind of the performance metrics in the UPF pipeline. So yeah, that's where we were currently, and hopefully we can update in a couple of weeks where we are with the other kind of methods. And with that, yeah, and almost I'm coming to the end of this demo. And if you have any specific questions, I'm happy to answer.
Thanks for the demo. I have a question. This is Larry.
Yeah.
When you were showing the configuration earlier,
Mhm.
and that you had the left hand and the right hand side,
Yes.
At the bottom of that, I don't know if you can go back to that or not, but
Okay. I can.
you can.
Mhm.
Yeah, at the bottom of that,
Mhm.
when you got to the very end of it, and you had some brand new stuff, my interpretation. Everything up to that point was just a particular configuration of what's already there.
Mhm.
And so correct me if I say something wrong here, but it seemed as though you had done something new, or my interpretation at the very bottom of that. And I was wondering, did you make any changes to the core there?
Did you
Or
make any
these are
changes?
entirely done through configuration changes? The
Yeah,
slice rate limit config.
yes, this is purely on the configuration. Nothing we have made any changes into the code or anything. It's purely just the configuration. So, and optimizing this to via the configuration. Just to increasing the limit, the rate limit. So, and if we have some, if we, I remember it was configured by default. This is having very low, probably 10 Mbps in that range. So that is having an impact when we push through the traffic higher. So that's why just we were just increasing the limit.
And can you make this config file available?
Yeah, sure. Yeah, we were in the process of pushing this into the Aether repo. So and we will make this default configuration kind of, and so, this can be easily refer when we are interested in running through the performance point of view.
So I don't know if this is the proper default Ether in a box configuration. I don't have an opinion about that, but just having this config file available as the high throughput config file so people can look at it would be.
Exactly. Yeah.
Just one comment to add in here. So what Suresh is showing there, all these changes, is what basically is using in this upf.json file. So basically that's what, if you go into the repo, the upf repo, that's all the different options you may have to configure the UPF or to set up in the UPF. So the whole, if you need the whole, everything that is configurable, you can also take a look into the UPF repo itself.
So there's a JSON file. Basically, this YAML file, whatever you said affects the JSON file. That's what it reads.
Exactly. So if you see in line, Suresh, if you go to the line, well, sorry, you are on video, but if you move the pointer up to the where it says the UPF JSON, right above the mod column DPDK.
Yeah, I see it. Yeah.
So that's basically, everything that is inside there, it's just basically to replace everything that is in the UPF JSON file.
Thank you.
So basically here you are overriding all those different parameters, and that's what is replacing the default UPF JSON that is actually being deployed.
Got it.
So all the different options you're gonna find in the UPF. I'm gonna share the link to that specific file.
Thank you. That's very helpful.
Mm-hmm.
Other questions?
Yeah, this is Sagar. So just wanted to talk about two things here. One is, I believe the speed test server that you tried was on the internet, right?
Yes.
Did you try to have a local speed test server as you did for this?
No. I
Do
haven't
you
tried.
expect? Yeah. Do you expect to see some changes there if you happen to have a local speed test server?
Well, I thought that was local. It was over a 10 gig switch.
Oh, no. With respect to the speed test server, okay, we were connecting the UERAN SIM to the UPF, but after the UPF, the speed test tool, what it will do is it will ping the servers located in the internet, and it will choose the best RTT servers. Then it will automatically upload some files. That's how the test tool is designed. So that doesn't give any control for us. It may, when you are running some 5 times of test, you may get 5 different values. So that is the problem we have with respect to the speed test tool.
Yeah, I just wanted to do some sort of a comparison, maybe in this case that if we have a local speed test server, how much it is giving us the value, and as opposed to when we have the local hyper server and the client.
Yeah, we haven't explored that path yet, and
yeah, that's completely fine. I mean, just this was just one thing that I wanted to ensure that. The other thing that I wanted to ask is, I understand that this was in the DPDK mode, and probably this may not apply here. I still need to double check with the Kajit team out here. But when the the GS Lab Kajit team started doing some sort of an on-field or pre-production related test, they came up with a flag specific to a network interface, specific to the network interface card, what is called as GRO, generic resource offload or some. So if we change
Yeah.
that particular flag, they see a significant change into the performance output or throughput output.
Yes.
Is that something that you configured here as well?
Yeah. I did that, but what I see in my based on my understanding, that will play a role if you are using AF packet mode. But I do not see that is really playing any role in DPDK mode.
Okay.
And on top of that, that affects TCP throughput. So in the UDP base, it doesn't affect the throughput in there.
Okay. And did we do any test on the AF packet in that case?
Yeah, we tried in AF packet mode as well, the same IPEF test.
Oh, okay. And so by default, I believe the flag is on. In that case, you still get the same close to 1 Gbps throughput?
No. The GRO flag is we have to enable.
So you have to
disable.
manually enable, and on top of that, that only affects TCP throughput. So if you run a typical UDP based throughput, it doesn't have any effect in there.
Okay, so just to summarize, is what I mean, just to understand, is we did try the AF packet mode with the flag on, but we tried the UDP traffic on AF packet mode. Is that the right understanding?
We tried UDP as well as TCP. So in order to get a higher throughput in AF packet mode, that GRO flag, whatever you described, that needs to be disabled. Yeah.
Right, and once you disable it, you are still getting to close to 1 Gbps numbers. Is that right? Even in case of TCP traffic, that's what I want to confirm.
Yes. So basically, that the flag plays a very significant role in AF packet mode.
Yes. Yeah. Okay. Yeah. Thank you.
I think one point to add, Suresh, is that you can also play around with that QCI QoS config part, which I see is commented here, where you enable or add values to the CBS, EBS, and PBS based on the QCI value.
Yeah, but initially we thought, okay, how did we take these approaches when we push the traffic higher? We do see if our pipeline drops, then we went and we just optimized the parameters with how to make it zero drops, right? At least in the pipeline. I'm not worried about external things, but at least in pipeline.
In the pipeline, yes.
Yeah, but I do not see anything. I don't remember I have changed anything with respect to the QCA QoS, but at least since we don't see any kind of drops or anything which impacts, I don't get a chance to play, but I can make a note. Probably we can try that, and whether it is helps in improving anything that.
Yeah, I think what Badri said break. I mean, I'll second what Badri said, because initially, I believe GS Lab Kajit team also faced few issues related to the PCF and PCRF settings there, and once you kind of tweak those settings there, you do see a good throughput.
Oh, okay.
Because it's kind of defaulted at 2048, like 2048 for QCI 9, which is probably the default QCI used for any UE that you attach.
Okay.
So if that is less, and this is kind of comes into this polyser and that part in the QoS part, so it might affect some packet drops. So if you do want to increase it and try it out,
we will.
Yeah.
Right. And the one last question. I'm sorry if I'm dragging this a little bit.
Oh, no.
Yeah. So you talked about the packet size to be 1300 in this case, right? Does this affect or does this affect the MTU size?
Does this affect the MTU size? No.
Yeah, I mean, typically the MTU size could be 1460 or 1500 or so.
Yeah.
So, look, considering the packet size, the headers and other things, if it goes
Yeah.
closer to the MTU and other things, then you may see a packet drops in that case. Is that right? And does it change if you happen to change the MTU size or increase the
Uh,
MTU size?
No, we haven't changed the MTU for these experiments. We just left the default one. And with this 1300, I do not see anything that impacts. But when you are changing this, the packet size, if you are reducing from 1300 to like 250 or 560, that if you just make halfway, then there is a lots of packet drops you can see, and that is impacting.
Oh, so if you reduce the packet size, you see a lot of packet drops.
Yeah. Like at packet drops in the sense, yeah, you won't get to the one in like 1 Gbps. Now we are getting almost 0.28% drop or something that will be increased to some 10-15%. I don't remember exactly the values, but yeah.
That's interesting. Reducing a packet size increases the packet drops, which means maybe the CPU is not able to route or parse the traffic in a way if the number of packets per second are more.
Yeah, number of packets increases, right? When you are just reducing the so.
Okay. Yeah. Good. Yeah. Nothing much from my side. Yeah. Thank you.
Anything else?
Just one question. I mean, overall doubt is how do you, what is the standard way of saying that, okay, this is the throughput for my UPF? Is it like we do it with one user and push it to the limit, or do you have multiple users and
We are
then try
in the
to?
Yeah, we are in that path only. For now, so far, whatever we have a kind of tested is with a single user with UE and SIM, right? So with a single core, whatever configured, we were pushing that and testing, and that's why we just plan to move to T-Rex, where we have a control of configuring multiple flows, and you can pump the traffic accordingly. So just now we were moved and we were in the process of that experimentation. Probably at the end of that experimentations, probably we might come up with the understanding and what we have. So at this point, everything is with a single user. So since we were using the UE and SIM.
Right, and with single user, we'll try to push this, whatever limitation that we put for slice race limit to from 1 Gbps to whatever the line rate is, and try to see how much of that percentage would we achieve. So that will give us one number, or do we plan to
Yeah,
stick to 1 Gbps or something?
no. I think as part of this experiment, we did push beyond 1 Gbps, but I think we do see some kind of packet drops, but we haven't concentrated there yet. So our intention here is at least 1 Gbps without any packet drops in the pipeline. That's where we were so far concentrating. So
Okay.
probably we can push beyond that using the single user itself, and we can configure this. Already we configure the rate limiting everything for 2 Gbps. So we can push beyond that and we can see. And I do see one problem there is if you are changing or pushing beyond that limit, my UE and SIM, that is breaking. So like when you are increasing the number of packets, I do see the connection, the UE connection is disconnecting, RRC releases, that kind of behavior I do see with the UE and SIM. So and hopefully with the T-Rex, we may have a control over that. So probably we can try that.
Okay.
So all this is simulated, right?
Yeah. Yes.
When we do have the actual phones and the UVs talking over the RFs, do we are we expecting to see a lower numbers than this?
Yeah, it depends on the other elements also, right? The G node base, the real one. What is there any limitations there which applicable? So at least we don't see anything with respect to the UPF point of view. There may not be much changes. But yeah, when we are using the real UEs, and there might be changes with respect to the G node Bs and other kind of configurations, right? The radio.
Yeah,
So
that,
to expand what Suresh indicated, so from UPF perspective, same performance. From the GNLV UE connection, that's where the RF is limited, and also you have all the NR layers on there that decreases the throughput a lot. So in the other project, as I mentioned, that we are currently working on, at least when we deliver the first demo, we achieve around like 50 megabits per second in downlink and 10 megabits per second in uplink. For a single UE, kind of like fairly close UE to the form fairly close to the USRP. Not ideal conditions, not an isolated environment, but it's way much limited what can be achieved on a real setup. But again, not due to the UPF limitation, but more for the NR perspective constraints.
yeah, that's a good point. And last time when we did in our GS Lab the testing with the real UV, we've got the similar readings about some 50 Mbps order download and some 70-ish or 20-ish MBs of upload. And this was the test with the real UV and the real eNode B. This yeah. That's what we've got. I am damn sure we did not have had a DPDK there. It was with the AF packet and with the GRO flag off, I believe.
Mm-hmm. Yeah, so that's
that's
again. Sorry, go ahead.
no, sorry, go ahead. Yeah.
Yeah, no, that's what I'm saying. So that's kind of like some testing that we actually did using a speed test, connecting to the internet in that case. Yeah, so but again, not due to a limitation on the UPF itself, but more on the NR side limitation, right?
Yeah. Yeah. Right. And when we are using the 10 Gbps switch, and that's why we are getting around 2 Gbps or whatever that limiting is. That's a fair value with respect to the infrastructure that we have, especially the switch.
No, sorry.
I didn't quite follow the question, but basically, we are limiting in this case due to the slice rate limiting. That's why you have just one gig in uplink and 1 gig in downlink.
Okay. Yeah, got that.
Suresh, you were about to mention something.
No, that exactly.
Anything else? Thank you very much. Are there any other topics that did not get covered that we need to cover?
Probably one kind of backlog comment that I had probably like 4 or 5 weeks ago. And I hadn't had a chance to join in the meetings because I was on vacation, but it's primarily with David about the Jenkins job for testing the UPF, the line rate tests of the UPF. So I just wanted to see whether there is any feedback or update on
Sorry,
that.
no update on that, been focused on other things. I'll take a look at it today again.
Okay, thank you.
No, my apologies. It's been too long.
No, don't worry. Don't worry. Again, I have been on vacation, so I haven't had a chance to look into that. But again, I'm just kind of like going back into different tasks I have pending. So, and that's one of the ones I would like to kind of start having some updates, making sure that the UPF is built, not just building, but running. I mean, running at least these line rate tests as expected.
Okay.
Thanks, Dave.
Yep.
Anything else? Going once? That's twice is enough. All right. Thanks, everybody. Again next week. Bye-bye.
Bye.
Thank you. Bye.
Thank you.
Hi, everyone.